Hi, I'm Xiao from Computer Vision Center. I'm going to present a joint work of CVC and MILA, Action-Based Representation Learning for Autonomous Driving. In our daily life, human drivers can produce a quite large amount of driving data. One big advantage of this data is that no intensive human annotations is required. So we raise a question about how could this data be used when building autonomous driving systems. One approach is to create end-to-end driving models that take sensor images as input and directly output the action for driving. This approach is very straightforward, but it has two main problems: the lack of interpretability and the difficulty in dealing with spurious correlations. Thinking of that, we try to find out if there is any other novel way to use this data. In our paper, we propose to use this data for representation learning. Instead of being used to directly drive, these models can also be used to learn a powerful representation. Our approach could be mainly divided in two stages. At the first stage, we use action-based driving data as supervision to train an encoder that could produce representations. Then, at the second stage, this pre-trained encoder together with an MLP modules will be used for predicting some driving affordances. These affordances are related to actual driving, such as a binary classification problem of traffic hazards or a regression variable like velocity angle. At the end, a PID controller based on these affordances will be defined to do the actual driving. One of our studies is to explore if the source of these data can come from random roaming drivers who produce data without following any traffic rules, or should come from expert drivers. Our paper results show that representation learned from the expert actions are much more better than the random roaming actions. So how does action-based pre-training outperform the general ImageNet pre-training? We take one of our proposed pre-training strategies, behavior cloning, named as BC here, for comparison. We show some attention map from which we could obviously see that the objects of driving hazards are much more highlighted by our BC pre-training encoder that trained with 50 hours expert data. We also did an ablation study on how does the amount of expert driving data actually affect the driving performance. We observed that the larger amount of expert data we use, the better driving results we can get. We show the differences by gradually increase the amount of expert driving data. At first, we don't pre-train our encoder but use only 30 minutes affordances annotated data for the second stage training. We could clearly see that the driving model mostly could not detect traffic hazards. Then we increased the action-based supervised data from 0 to 5 hours. The model sometimes is able to detect hazards, but it is very unstable. Next, we increased the expert driving data to 50 hours. With this strong pre-training, the model is always able to detect hazards. The only issue is that it could sometimes misclassify the hazards, which is because of the lack of affordances data. So at the end, we also increased the affordances annotated data to 5 hours. In this case, the detections are pretty satisfactory. So in our paper, we propose that representations learned by using action-based methods are promising for autonomous driving. Also, we found driving data that comes from expert drivers is a key to obtain a better representation. We also found that by increasing the amount of expert driving data for learning the representation, the driving performance can be clearly improved. As a future work, it is worth to explore if these pre-training strategies is also helpful for training annotation-intensive vision tasks. Thanks for your attention.